Hey guys, today we're going to be talking about exponents, but kind of some special scenarios when exponents are negative and when exponents are zero. Now, let's get the easy one out of the way first. Zero exponents. Something like 4 to the 0 power. Now you may have been thinking like, oh, well, 0 exponents, that's just a number without an exponent. Just a number like 4 on its own. It's not. Any given number that doesn't have an exponent written up in that corner actually is to the first power. I know, it's kind of weird, right? But it is. It's like, it's just itself. It's to the first. It's just 4. But it is possible to have an exponent of 0, just like that. 4 to the 0 power, or maybe 3 to the 0 power, or 127 to the 0 power. Anything can be written to the 0 power, even x to the 0 power. Now here's what might surprise you. Every one of these, all 4, even though they look completely different, are all equal to the same thing. Any number or variable to the 0 power is equal to 1. So all of these, no matter what, equal 1, even if it is a variable. This is the only instance where we can actually take a variable to an exponent and not know what the variable is, but still get a whole number value. So even x to the 0 power or y to the 0 power is 1. That's x to the 0, or that's 0 exponents. Let's talk about the kind of more complex one, and that's negative exponents. So let's say we have something like 5 to the negative 3rd power. How would that work? How do you have a negative exponent? We've talked about exponents being the number of times the base multiplies itself, right? How does that base multiply itself negative times? It's so weird. Well, the reality is that a negative exponent, this negative sign here, what it really means is that this number, actually let me say this base, is on the wrong side of the fraction. Now, I know what you're thinking. You were with that definition until I said the word fraction. Where's the fraction at? Well, here's the idea. All numbers are fractions, right? Even if they're just written as a 5. We've talked about that before. A number like 5 can be written as 5 over 1. Any number can be written over 1 to make it a fraction. The fact of the matter is that a negative sign in an exponent means that the base, or the number it's with, in this case the 5, is on the wrong side of the fraction. So what we actually want to do is we want to get that 5 on the right side of the fraction. Well, there's only 2 sides. There's a top and a bottom to it. So what's going to happen is, to make that exponent positive, we take this 5 and its exponent of a 3 and we flip it around to the other side. So now the denominator is 5 to the positive 3rd, because it's now in the right place for it, and the numerator is 1. So we can solve this at this point by saying, well, 5 to the 3rd is 5 times 5 times 5. So it may as well be 1 over 5 times 5 times 5, or 125. That's the actual numerical equivalent of 5 to the negative 3rd. So the really big thing to just remember here is that a negative exponent means we flip the side of the fraction that number is on. So let's say we have something like, 1 over 6 to the negative second power. That negative exponent, that anytime we see a negative in front of our exponent, that means this is on the wrong side. It needs to be on the other side of the fraction. So I'm going to take this whole thing, 6 to the negative second. Apologies about the bell. So I'm going to take this whole thing, 6 to the negative second, and flip it up to the top of the fraction. So 6 to the negative second, or 6 to the positive second, is now going to be in the numerator because it's where it's supposed to be. And anytime you take things away from a numerator or denominator, anytime you move that stuff away, you leave a 1 in its place. Now, 6 squared, we can simplify to be 6 times 6, or 36. And any number over 1, do we really need to write it over 1? No, we don't. It's just 36, plain and simple. We're going to do one last example here, and that's going to be x to the negative 4th over y to the negative 3rd. We have variables in this case, and these variables with negative exponents. So what's going to happen is we recognize this x in the negative 4th, it's in the wrong spot. It's negative. It's not feeling good being where it's at. It needs to be positive. It's got to move. It's destined to be down there. However, the same thing is happening to the y that's already in the denominator. That y is not feeling good. That y is like, I need to be somewhere else. I need to be up there. So we have to do both of these things. The y moves to the top of the fraction, y to the positive 3rd, and the x moves to the bottom of the fraction, and it becomes the positive 4th. And it looks just like that. Now we can't do anything more with this because we don't know what x and y are, so that's about as simple as we get our answer to be able to be written. But they're now positive exponents that are where they were meant to be, pretty much. That's the idea, though. If you have a negative exponent, you want to flip the side of the fraction that number or that base is on. If you have a 0 exponent, well, guess what? It's just 1. That's all there is to it. If you have any questions about this, feel free to drop a comment below, or let me know, and I'll try to get back to you as soon as I can. Otherwise, thanks for watching, guys, and I'll see you next time.